In this video, we will explore new possibilities for building automated decision-making systems using the RAISON platform. We will revisit the project created in the first video and explore how different situations can arise compared to what we previously examined. In the first video, we analyzed the use case where a common scenario enables two competing or conflicting decisions and explored various conflict resolution strategies to determine the final decision. In this video, we will explore the use case where different scenarios apply to the two available options. So I will delete the scenario we created last time, and before creating new scenarios, I will click on Manage Elements to review all the stored information or elements created during the previous decision-making policy modeling. We will see how we can reuse these elements for this new modeling. Let's consider a new scenario: nice weather. Here, nice weather refers to conditions where it is not cold. We will associate this scenario with the option go to the restaurant, meaning that when the weather is not cold, I prefer dining out, or I have a valid argument for choosing to go to the restaurant. Let's now create a second scenario: nice movie on TV. We will associate this scenario with the option stay at home, meaning that when there's a nice movie on TV, I prefer to stay in. As we can see, there is no conflict between the two options because each scenario supports a different decision. Looking at the decision policy, we observe that for nice weather the decision is go to the restaurant, and for nice movie on TV the decision is stay at home. I click Run and RAISON generated the code for a system which is deployed and ready for use. We can then test this system using different scenarios. If we choose nice weather, the decision is go to the restaurant. If we choose nice movie on TV, the decision is stay at home. However, if we select both, we see that both decisions are possible. This is fine if we don't need to make a clear or definitive decision between the two options. But if we do need to decide between go to the restaurant or stay at home in this combined scenario, we must go back to the editor and refine the decision-making process by combining or merging both scenarios. We can do this by clicking on Compatible Scenarios and selecting the two initial scenarios to create a new combined or merged scenario. Then if we click on the conflict resolution, we can see that RAISON has detected a conflict between the two competing options. In this situation, we need to resolve the conflict by selecting the scenario. RAISON presents me with the three different possibilities we explored in the first video. To recall, Primary choice means making a decision without adding any new information to the initial scenarios. We can choose one of the options only based on the information in the initial scenarios. The second situation is to add context, which means that in order to make a decision or to make a choice between the two options, we need to add more information in the initial scenarios. The third situation is when we consider that all options have the same value and we can then choose one at random. Let's consider add context. We can prefer go to the restaurant option if we add a new element. I have an invitation. Similarly, we can prefer stay at home option if we add another element. I feel tired. At this point, RAISON asks me whether this scenario is coherent, meaning whether we consider a situation with nice weather, an invitation, a nice movie on TV, and feeling tired to be a realistic scenario. Obviously, the answer is yes, this is a possible scenario. At this point, we can make a choice by considering the two possibilities, primary choice and add context. Let's start with primary choice, meaning we express a default preference in this combined scenario. We choose stay at home because feeling tired is more important, or takes priority, than accepting an invitation, and this may be a criterion for making our decision. Now, RAISON asks whether we can add more elements to prefer go to the restaurant option. We choose no. This takes us back to the previous step where we added new information to support our decision. At this stage, we have the opportunity to introduce alternative information that allow us to express a different preference and explore new solutions beyond the ones previously selected. This alternative information represents another reason for choosing an option distinct from the reasons introduced earlier. I feel tired for staying at home and I have an invitation for going to the restaurant. It is introduced at the same stage of the conflict resolution process, where the combined, or merged, scenario includes nice weather and nice movie on TV. Let's then consider now an alternative reason for choosing the option go to the restaurant, for example, the presence of a new restaurant to visit. At this point, RAISON asks whether this new combined scenario is coherent. We observe that this scenario now incorporates elements from the initially combined scenario, nice weather and nice movie on TV, as well as the previously added reason I feel tired, supporting stay at home, and the newly introduced reason new restaurant, supporting go to the restaurant. Since this scenario is logically consistent, we click yes and we proceed to make a choice. To refine the decision further, we may introduce additional context, for instance, preferring stay at home if it rains. At this point, RAISON offers the opportunity to add more information in favor of go to the restaurant or alternative information in favor of stay at home, but we decide not to and click Finish. Now, we return to the previous step, where RAISON has constructed the combined scenario that included new restaurant and I feel tired, alongside the initial elements nice movie on TV and nice weather. RAISON then prevents us from considering an alternative situation. What happens when we combine new restaurant with I have an invitation, as both serve as alternative justifications or reasons for choosing go to the restaurant? Similarly, if we were to introduce new supporting information for stay at home, RAISON would ask us to evaluate its interaction once with the new restaurant and another time I have an invitation, both justifying go to the restaurant. Since we decide not to introduce any further information, we finalize the conflict resolution process. By clicking on Decision Policy, we can view the different policies we have created. We can observe that, for nice weather the decision is go to the restaurant, for nice movie on TV, the decision is stay at home. When both scenarios occur together, both decisions are considered valid. When we add the additional information I feel tired, the decision is stay at home. If we add I have an invitation, the decision is to go to the restaurant. Similarly, when we introduce new restaurant as an alternative reason, the decision remains go to the restaurant. When the scenario includes nice weather, nice movie on TV, I feel tired and I have an invitation, the decision is stay at home. When the scenario includes nice weather, nice movie on TV, I feel tired, new restaurant and it rains, the decision is again stay at home. Now, we click the Run button, and RAISON generates a new code for a new system, which is deployed and ready for testing. Let's check the decision policy now, selecting nice weather results in go to the restaurant as expected. Selecting nice movie on TV results in stay at home. Selecting both nice weather and nice movie on TV presents both decisions. Adding I feel tired results in stay at home. Adding I have an invitation results in go to the restaurant. Adding the alternative information new restaurant again leads to go to the restaurant. When selecting both I have an invitation and I feel tired, the decision remains stay at home. If new restaurant is chosen along with it rains, the decision remains stay at home. Now, let's return to the editor and consider another use case. I will delete the two initial scenarios and introduce new scenarios. Scenario 1. The element day off is present, and in this case, our preference is stay at home. Scenario 2. The same day off element is present, but now combined with nice weather, where we prefer go to the restaurant. Examining the decision policy. For day off and nice weather, the decision is go to the restaurant. For day off, the decision is stay at home. Since these are distinct scenarios with clear decisions, there is no conflict. Running the system confirms that selecting day off results in stay at home. Selecting day off and nice weather results in both decisions being available because stay at home is supported by day off, while go to the restaurant is supported by both day off and nice weather. However, if we want to ensure a single decision in this situation, such as always preferring go to the restaurant, we need to return to the editor and merge the two scenarios. When we do this, RAISON detects a conflict that needs to be resolved. We will resolve this conflict by selecting primary choice, allowing us to specify our default preference. In this case, we choose go to the restaurant as the final decision. Since we do not wish to add new information for supporting stay at home, we proceed with this selection. We click on Run and RAISON generates new code and deploys the new system. Now, when selecting day off and nice weather, only one decision is presented, go to the restaurant. This use case illustrates how we can model various situations where shared elements appear across multiple decision-making scenarios and we are forced to make a single, final decision. This concludes the video. Thank you for watching.